So a lot of the words we're going to use, and we're carrying on from the last lesson that we did. So a lot of the words we're going to use we've come across before. I'm going to dive into some in a bit more detail. I'm not going to do too much in one session because electromagnetic waves, electromagnets and magnetism and magnetic fields inside wires with current is not an easy topic. So I'm going to pick two parts, and we got a set of easy questions, and that's just recall. So what I mean by so in your any kind of analysis, this is what we call AO1. What can you tell me that I've told you? Okay, that's AO1. Understanding is AO2. And the way to look at AO2 is something happened because. So it's almost like you have to use the word because in an answer to it. Application and reasoning, this is what we call AO3, assessment objective 3. And this is for problem solving. All right. These tend to be the worst ones that are answered. All right, in any exam. So yeah, AO3. Okay. So now that I've gone through the kind of questions you've got, I'm going to go through the content. Okay. So when there's a current in a wire, so we're looking at a wire, right? So any current, any movement of charge creates a magnetic field around the wire. Okay. The field lines are concentric circles, and you know me, I like images. I don't like being told stuff like that. Oh, hold on. Oh, excuse me. So I like to be able to see things. And what we mean by concentric circles is circles within circles. Let's make that a bit smaller. Let's bring it here. Let's zoom in. Okay. So if we look at the first picture, the arrow tells us which direction the current is flowing, and it's upwards. So this is Fleming's right hand thumb rule. You use your right hand. Now, if you look at this, the thumb is pointing upwards in the same direction as the current. Okay, that arrow there is the current. If you look at the fingers curl around like this. And the fingers are in the same direction as the magnetic field lines. These are the magnetic field lines. Okay, so this is the direction of the magnetic field lines, and that's the direction of your fingers. How we expect you to draw them is, if you think about it, if this is the piece of paper, that grey thing is supposed to be a piece of paper, like your test paper or drawing paper or something. If you're looking from top down, you draw the wire and you put a big circle in it. And the circle means the current is coming upwards out of the paper, which we can tell because your thumb is pointing upwards. And then you draw the circles, the concentric circles, and the arrow going the same direction as this, like you're looking top down. Okay. Now, if, and imagine it, you're still using your right hand and the current changes direction, so instead of the current going upwards, it is now going down. Well, you're going to put your hand upside down. So your thumb points downwards, right? Now, if you look at the fingers are wrapped around this way. So that's the direction of the current in the concentric circles. How I would draw that is for a circle with an X, meaning the current is going down. So if this is my piece of paper, my test paper, my exam paper, my experimental paper, the current is going down through your paper. So just draw an X to say it's going down through your paper. And the concentric circles, the arrows are going that way. Now, this is really tough. This one isn't bad. So the first one isn't bad at all, image one. It's image two that starts getting a bit silly, all right? And really awkward to do. Can you imagine an exam going, like, come upwards? And oh my God, it's so annoying. So what I tend to do is I tend to do that. I check, is the current going upwards? Well, then it makes my life so much easier. And then just draw it. Now, if it's going downwards, I still do it like it's going upwards, but I switch my arrows the other way around. All right? And that's me being cheeky because I'm not as flexible as I used to be. So that there is how you deal with electricity, current, charge flowing in a wire and the magnetic field it creates. Okay. So, what else can we talk about in terms of that wire? Well, there's an obvious one. The closer you are to the wire, the stronger the magnetic field. I mean, that's almost like saying, well, yeah, obviously, that's not unexpected. This is the right-hand thumb rule that I've just gone through. Last week, I should really move. I'm going to move all this down. Last week, I mentioned solenoids, and I said, look, we tend to talk about solenoids and make it sound really complex. Well, a solenoid is just a coil of wire. Okay, and it looks like this. Well, I just said solenoid. That really doesn't want very much to do. I want to get an image of it. So, a solenoid is just a coil of wire, and the current flowing through it. Okay, let's go back up over here. Let's put this image down here. So this is a solenoid, and we had a very, very brief look at it last session. Now, and again, a really weird looking thing is we can work out which one is the North Pole and the South Pole. Okay, and the way you do it is with your right hand again. Okay, now you have now I will tell you what I look at. Okay, have I put it up there? Yes, it's changing to here. So the way that I look at it is a solenoid. This is, let me get a large pink pen. My current is flowing up and around and around and around and around. And you see which way it's flowing? That's a bit thick actually. Let's make it a bit thinner. So my current is flowing around and around. Now look very carefully. It's going the same direction as my fingers. My fingers are wrapping over the top like this. My current is flowing in the same direction as my fingers. And my thumb will point to the North Pole. All right? And that's it. I don't really look at that in terms of end view. I've never really seen a question like that on the end view in any exam paper. Let me think. Nope. Any test paper. I have seen which one's north and south. Or draw the field lines in a solenoid. Okay? Make sure your fingers flow in the same direction as the current. All right. So, right, solenoid. Coil of wire. It behaves like a bar magnet. We did that last time. One end is North Pole and the other South Pole. Obviously, it's acting like a bar magnet. This is looking at the ends, clockwise or anti-clockwise. I just don't bother. It's too complicated for me. I just grab it, making sure my fingers go around the same direction as the current. I also mentioned last time, if you add an iron core, you change it into a very strong electromagnet. The more current you have, the stronger it is. The more turns you have, the stronger it is. If you go on iron core, the stronger it is. So there's parts of this that we've done last week. I don't want to throw too much at it. I want to do a bit more work on Fleming's left-hand rule in the motor effect next session. But that's what we're doing. You've got a set of questions. Dun, dun, dun. There they are. So I've tried not to add too much content. What I've tried to do is change the difficulty of the questions.